that y'all have coming up. And so I will encourage everybody not to wait till the last minute, because it always takes longer than you think it's going to take. Also, I'll encourage you to make an appointment with me to test out your code before you go, because it'll be great if the night before, when everybody else is staying up late to try to finish it, you say, oh, I've already tested mine, it works fine, and you'll be good to go. So let's take a look at what this project is. It's a variation of, it's another variation of the elevator project that has been being used for Digital Logic Lab for a long time, and but it's not exactly the same, so you cannot just reuse code from someone else, or if you're retaking the class, reuse your own code, because it's not going to work because it's slightly different. So so don't try that. It'll end up, in the past, when people have tried to reuse the code from someone who had done it a previous time and just try to modify it, it ended up taking longer than if they had just started on their own, because of all the changes, and then you have this error and then you have that error. So I just recommend that you not try that. Okay, so it has 4 input switches, so you have 4 different inputs and 1 LED output, plus the 7-segment display as an output. And just to start off with, that is different. So that's so the inputs and outputs are different from previous years. And if you have been like me, I end up always having errors with my constraints. And so if I wanted to try to change the inputs and outputs, that would be a problem. And the way it works is the switches represent the floors, and pressing the switch represents calling the elevator to that floor. And then every time you press the button, the elevator advances depending on where it is. And so like if it's on the first floor and the third floor switch is switched, then it's supposed to head to the third floor. And then it has a light to show whether the door is open, because when it arrives at the floor, the door is supposed to be open and be open for 2 clock cycles. The 7-segment display is supposed to show the current location of the elevator. The 7-segment display shows what floor it's on. Now these details are what's important. So the system indicates conditions such as the elevator is on the first floor and the door is open. So the 7-segment display will show what floor it's on. The LED will show whether the door is open or not. The elevator should remain at rest until someone presses a button. The door is closed in a rest state. So if all the switches are off and you press a button, it shouldn't do anything. Shouldn't go anywhere. If someone presses the first floor button, then the elevator should go to the first floor, open the door, and remain on this floor with the door open for a small amount of time, and then close the door. Assume the elevator takes 1 clock cycle to travel from one floor to an adjacent floor, and that the floor stays open for 2 clock cycles. So the first time I did this, I had a state diagram that had, if you're on the first floor and the only switch is to the third floor, then in the next state you go to the third floor. And a lot of people used my idea, and everybody did fine except for one person. And then because the TA said, well, you can't just go straight to the third floor in 1 clock cycle, it's supposed to take 2 clock cycles, because you're supposed to go through the second floor. And so that happened once, so something to keep in mind.
So it can't go straight from one to the other like instantly?
Right, it should take 2 clock cycles.
Okay.
So on the first clock cycle, it shouldn't be, the door should be on the second floor with the door closed.
Okay.
And then the next one, it should be on the third floor with the door open.
So it takes a clock cycle for each floor.
Right.
That one.
Right. So if the elevator is on the first floor and both the second and third floors have been requested, it should go to the second floor before the third. Similarly, if it's on the third floor and both first and second have been selected, it should go to the second floor before the first. And you can choose a reasonable behavior if it's on the second floor. There's one thing that's different.
This sounds so complicated, I'm not gonna lie.
It's really not.
How do you
I feel like I can't do it.
There's a hold a door open. So this was new. It's really not. And I'll tell you how to make it not complicated. And I'll tell you what people do to make it complicated, because the way you're thinking about it right now, it does seem very complicated, because you're used to thinking in programming languages like C++ or something like that, and you're thinking, okay, if this happens, then I have to do this, and then I have to do this. Okay, but if this happens, then I have to do this, and that's not going to be the best way to think about this. And I'll show you what I mean by that in a minute. So you have the hold door open button, represents a button located inside the elevator that when the door is already open will hold the door open as long as the button is pressed. Use switch S5. So if you're on a floor and the door is open and that switch is pressed, then it'll stay open. What you want to do is to use a finite state machine, and you want to have lots of states. And then it becomes a matter of just saying, what happens if I'm in this state? You have 4 switches. What happens if I'm in this state based on those 4 switches? And then you just go to that state. And so it's a lot of states. And so if you think about what your different states could be, what you don't want to do, what people do every semester is they come in and say, okay, well, what is this part of the code? Oh, well, this is where it's opening the doors. That's not part of the code. You have a state with doors open, and you have a state with doors closed. You don't have a procedure for opening doors. Well, now it's going to go to the second floor. Well, you're not really going to the second floor. You have a state where you're on the second floor. You're going between states. So what kind of states might you have? You might have states like, we know we have the states for the 3 floors.
It's gonna be like this. I feel like it's gonna be like the same amount of states as like the vending machine we were doing.
Way more.
Way more.
If you do it the way I'm suggesting. People always want to not do it the way I'm suggesting because it says, well, that's too many states, and then they want to put some programming in instead, and that's where the Verilog is going to mess up. They want to put a lot of ifs in there. Now, what I can show you is, because there are 4 switches, that means there are 2 to the 4th different combinations of inputs. So that on the surface, that seems like you would have to have 16 different things for each state to say what to do. I'm going to show y'all later how you don't have to do that, because you can have a case statement where you can collapse a bunch of those things into one.
Under a default or something?
Well, you can do like case 4B1XXX. So like if the door hold open button is pressed, you don't care what the others are.
I see. Okay.
So you don't have to do all 8 because if the door hold open button is on, you don't care what the others are. You're just supposed to stay there.
It's gonna be like a bunch of don't cares.
And so like you're not going to have 16 different things for each state. So you'll have a state for each floor with the door open for when you first arrive on that floor. And then you'll have a state for each floor that you go to with the door open for your second clock cycle. Because remember, it says it's supposed to stay open for 2 clock cycles. Then you'll have a rest state for each floor with the door closed.
So what's the first 3 again?
So
What state is that?
first floor, second floor, third floor.
Yeah, but like
So when you first arrive, the door is open.
oh,
Then it has to stay open for another clock cycle before you can go anywhere.
okay.
Then if you stay there, no button is pressed, you go into the rest state. That's with the door closed. Okay, you can also have I think, I haven't done it yet, you can probably use this state for also the state where you would go, you could go to another floor here, or you could stay here. So like, if the door hold open is pressed, I think you would just like stay in this state, if the door hold open is pressed. And then you have your rest state with the door closed. And then for floor 2, I think the easiest thing is to have, for floor 2, you have your closed on your way up and closed on your way down. Because if you're going from the first floor to the third floor, you have to go through the second floor, but you're not stopping there. You only really have one place that you can go after that, depending on the buttons, but that's, I think you would need those. And then I think there are more states than this. This is just kind of getting you started to be thinking about it. And then you just need to figure out, if you're in one of these states, what state would you go to based on your inputs? And then you just do a finite state machine for that. And then your outputs will be based on what state you're in. So you'll have your outputs are a 7-segment display. And so that's pretty easy to see what that would be. That would be, if you're in one of these 1 states, you would output the 7-segment display to be 1, and 2 would be 2, and 3, whatever. And then the open, if it's open, you have the LED on, and if it's closed, you have the LED closed. So if you, to give you an example, this is not, oh, I probably actually don't have it on this computer.
Have you been recording?
I have been recording, yeah. If you go back and look at YouTube videos from semesters past, you can see some examples. But my finished code from last semester was really just 2 or 3 always blocks, like an always block for, you know, going to your next state, and then an always block to advance the clock, and an always block for doing the displays. So it really was not, it was long because there were lots of states, but the being able to use the don't cares helps. Now, with the don't cares, this is a little trick that I learned. Rather than saying case, you do case Z. And case Z makes these don't cares work nicer. And I will be giving y'all lots of more information on that. Okay, so now let's look at the problems that are like the homework that's due for tomorrow. So the first one is I think, do the state assignment for yeah, it's, in order to make the light come back on, you have to like move over there. Yeah, you have to actually stand, it's like the motion detectors.
Yeah, I see it.
Yeah.
Right there. Yay!
I'm already falling asleep. I can't have that.
I know, I can see you falling asleep over there. It's like,
It's
I'm so boring.
No, it's not that. It's the average sleep cycle of an engineering student
Yeah,
is 4 hours.
yeah, that's about right.
Oh, really?
No.
It is for me. It's like, I don't,
I feel like that's what it should be, but it's probably one.
That's why.
Well, I'm just
Should be.
okay, so this is your homework question for tomorrow. The Verilog code is a sequential circuit with 1 input and 1 output. Draw the state diagram for this circuit. So I'm looking at this, and I can tell whether this is a Mealy or a Moore machine by looking at it quickly.
I guess you
What?
I wouldn't.
What happened?
So,
guessing.
okay.
That's right.
All right, so let's take a look at the problem that I gave y'all. And so if you go to the worksheet, it is, I copied this from my phone, so actually, I don't have it on this, I have to go download it from SI Resources.
output doesn't deal with the current,
Okay, so if we look at this one has, the output is T. And if you look at the code I have here, T depends on the input. T depends on R. So in this example that I gave to y'all, the output depends on the input. In your homework, does the output depend on the input?
no.
No. So that means whatever kind of machine we're doing here, your homework is going to be the other kind. So here it says we're supposed to give the state diagram. This is problem number 4. You can tell what your states are by your parameters. So this one has 3 states. So I have states A, B, and C. So I will draw 3 states. Does your homework say state diagram or state table?
I think it's, well, diagram at first.
Okay, A, B, C. Now, mine, the one that I have here is mealy, so I won't put my states, my output on my states. If it was more, you would put your outputs right on the states. We'll look at an example of that next. Okay, now I look at my code. It says A, if R. So if R is 1 and I'm in state A, then my next state is C and my output is 0. Else, I'm in state A, so that means R is 0, but my output is 1. If I'm in state B and R is 1, then my next state is A. And my output is 1.
Where can I find you this one?
This is number 4 on my handout in SI Resources.
Oh, okay. Alright.
Oh, or right there, yeah.
Man. See, this is why I failed.
You're just tired.
And else, so if R is 0, my next state is C. And my output is 1. And if I'm in state C, if R is 1, then my next state is B. And my output is 0. And if I'm in state C and R is 0, then my next state is A, and my output is 0. Now I'm going to change this up a little bit. So I'm going
Whenever
to,
it goes from B to A, is that 1, 1?
that's 1, 1. So I'm going to change this up, and we're going to have similar but not the same. So I'm going to have actually. Okay, so I'm changing my first always block to have my case statement look like this. And I'm going to change my second always block to look like oh, I forgot something in the diagram that we did. In this diagram, if you look at the second always block, it has if reset n equals 0, y equals a. That means that reset goes into a. Let's see how I did it. Okay, so I'm changing my second always block to look like this. So I still have three states, A, B, and C. But this time, it's a Moore machine and my output doesn't depend on my input. So how do I label my output on this?
Inside the circles.
Inside the circles. And what's the output gonna be?
1 for A, 1 for B, and 0 for C.
Yep. And that's because it says if y equals A or y equals B, then t equals 1, else t equals 0. Now, I could have set this up in just one line. I could have also said this. T equals y equals A or y equals B. That one line also gets me the output that I want because these have a truth value. If y equals A, then this has the value of 1. If y equals B, then this has the value of 1. And a 1 or a 1 is a 1, or if one of them is 1 and one is 0, that still has the value of 1. But if both of them are false, they both are equal to 0, and then t equals 0. So I could do this in one line without having to do an if-else. Okay, and then my case statement just says from A, I go to C, regardless of my input. From B, if R is 1, I go to C. Else, I go to A. And from C, if R is 1, I go to A. And if R is 0, I go to B.
Is A to C 0?
A to C is 0 or 1,
Oh, okay.
because it's the same, so I didn't put anything, it doesn't matter, it always goes to C.
Just like it's just purely sequential.
What's that?
Purely sequential.
Yeah. Okay, so I'm gonna stop this one.